All right. First thing, I apologize. I don't know where this came from, but this isn't the givens. Obviously, if you look at what I have actually given you and what I wrote in there for you, it's not the same. So let's just make sure we know what the actual givens are here. Okay, this is a rectangle, and M is the midpoint of WX. We need to show that the middle triangle is isosceles. All right, middle triangle is isosceles. All right, so I'm going to first ask somebody here. All right, if the middle triangle is going to be isosceles, what do you need to do with that middle triangle then? What's going to make it isosceles? That's my question. What is going to make it isosceles? Here we go, 24. 21, what's going to make this triangle isosceles? Okay, I need two sides congruent, probably those two sides, right? So how do I get those two sides congruent is my question. How am I going to get these two sides? First, by probably proving what we've done. I know we've done this a lot. 11, nope. 23, by doing what first? All right, let's do it. All right, let's try to prove the triangle's congruent. You and your group, I'll give you 30 seconds. Hold on, before I give you 30 seconds. Can we just get rid of M? M is the midpoint? What's true then? Because that'll give me a pair of sides right away. If M is the midpoint, what do you have for me? 21, what if M is the midpoint? Okay, let's put that in there first before we get to the rectangle business. So WM congruent to MX, definition of a midpoint. So that gives me a pair of sides. All right, now I'll give you that 30 seconds. Using a rectangle property, find me some other pairs that are congruent. Go ahead, 30 seconds, and then we'll report back. What else is congruent? Don't write anything down. Don't write anything down. Just discuss it in your group. Don't write anything down. Rectangle properties. Okay, here we go. Let's come on back. 6. Almost had me. We have a 6, yep. 16, you're on deck. What do you got for me?
WZ is congruent to XY.
WZ congruent to XY. Everyone agrees? All right, WZ congruent to XY. What do you think my reason is going to be here? Think about what we did for a parallelogram. It's going to be the same thing, except now I put what figure? Rectangle. Rectangle implies what property was just used here? Opposite sides congruent. All right, nice. I got a second pair of sides. Got a second pair of sides. Now, this is why I didn't want you to write down anything, because this next pair can be done right away instead of your usual 2 steps. What else is true because it's a rectangle? We've heard a lot of it from 21. 12. Anything else you and your group discuss?
We said angle W is congruent to angle F.
Okay. I know W and X are right angles, making them congruent. Usually we have to say what? They're right angles. Then we have to say they're congruent. But because this is a rectangle, it means all the angles are congruent anyway. So I don't even have to mention any of the right angle business. I can just say right now, angle W congruent to angle X. Rectangle implies all angles congruent. That's only for a rectangle, though. Okay, I still got to say it's a right angle, and right angles are congruent if it's not a rectangle. Everyone all right with that? That is a little nice, right? That is nice. I don't have to go through all that. I can just say they're equal right now. I think I got enough info to say the triangles are congruent. And what method is that going to be? 7, what method? Another number I got to remember. Great. 23. There you go. Side angle side, everybody. That's not done with the proof yet, though. Triangle Z, WM, congruent to YXW. And remember why we wanted the triangles congruent? So we could say side MZ is congruent to side MY. And I know it's been a while. Just want to make sure we're good. Why are those two sides equal now? 13? Darn right. CPCTC. And then it looks like that middle triangle is now isosceles. What's reasoning? Don't give me this in a triangle, congruent angles across. That doesn't tell me it's isosceles. What makes this triangle isosceles? What did we just do? Prove what? What do you have congruent here? Go ahead, fellas. I don't care who.
I said on opposite sides congruent by isosceles triangle.
That's not an isosceles triangle, but has opposite sides congruent, right? We just proved what here? Two sides congruent in a triangle. There you go. That's what you needed there, Zach. All right, in a triangle. All right, two congruent sides in a triangle imply isosceles triangle. There you go. Questions on this one using the properties? All right, I am going to skip over the next one because that's our new proof, and I want to wait to the end of class and do them all together. So let's go to the rhombus statements and reasons proof. All right, the third one in your All right, now it's a rhombus now. Now it's a rhombus, and I want you to prove FE congruent to DE. And also make sure you know we have a pair of angles that are equal. FAB is congruent to DCB. Only how are we going to get FE and DE congruent? By proving? Okay. You and your group, you know the deal. 30 seconds. Give me a rhombus property that's going to help prove the triangle's congruent. Talk it over. Don't write anything down. Just talk it over. Give me a rhombus property that will help me get the sides and angles. Rhombus properties that would help me get a side or an angle. Okay, going back. Give me a rhombus property that's going to help here. 6. What do we know is true here, but using a rhombus property? Okay, EC. You sure you want to say it's congruent to AB? That is true, but it's not in my triangle, though. AE. Everyone agree here. EC congruent to AE. Both sides of my triangles I'm trying to prove congruent. So EA congruent to EC. All right. Based on everything we've been doing here so far, how do you think I'm going to write this reason? How's it going to start? Rhombus, good. Rhombus implies what property was just used here? All sides congruent. Good. We're picking this up. There's a side. Any other groups apply any other rhombus properties here? If not, go back. Let's go. Another 30 seconds then, if this is what you got. There's one more. Don't tell me about the vertical angles. That's done. I'll put that at the end. I don't want to hear about the vertical angles. I want to hear about a rhombus property that I can apply to this proof. Talk it over. There's one more rhombus property that can be used here. And I'm sure it has something to do with the given we haven't used yet.
Say that.
A little bit tougher than the rectangle one. That's fine. Remember, that given's there for a reason. That given is there for a reason. Think we got something? All right, here we go. 7. Oh, I'm not gonna. 17.
We said that angle AAB and DCB would converge.
Everyone see those angles? That's a property that says they're congruent. What are we going to do with them? That's on to somebody else, I think. So angle EAB is congruent to angle ECB. What are we going to write here for the reason? I know it's going to rhombus. All right. How do I use that in the given one to get to an angle inside the triangle? I can actually use subtract them. There it is. We're going to subtract, everybody. So we can say EAB, big angle. Nope, sorry, that's not the big angle. FAB. Angle FAB minus EAB equals DCB minus ECB. Subtraction. And substitution to say the angles in the triangles now, which are FAE and DCE. Everyone's all right? Substitution. And then now you should have enough information to say the triangles are congruent. Triangle FAE congruent to triangle. Oh, no, I don't. Nope. Relax. I'm not. I caught it. You didn't get me. Sorry. You didn't get me. Still missing what? Vertical angles. I talked about it, but never put them in. Angle FEA. Man. FEA and DEC. And then we're good finishing this. The only thing I'm going to need to know from somebody is a little method here. Because it could be angle side, or it could be angle side angle, right? Just finish this off. What method are we going to prove these triangles congruent by? 8.
Angle side angle.
Good, angle side angle, and then CPCTC, which you guys can finish right now. Any questions with these? Just got to know your properties, so you'll be fine. All right, I'm not going to get real tricky on these proofs. You just got to know your properties. Because if we don't know our properties, right, we don't know sides or angles are congruent, unfortunately. Going? All right, you ready for this new type of proof? Okay, here we go. Let's go back to question number 2. Now we're going to do these proofs when our figure is on the graph. All right, our figure is on the graph. So I'll give you a second. Go ahead and graph that quadrilateral at those coordinates. And we'll talk. A little bit different now. You will not see a statements or reasons column anymore. All right, everyone have a graph ready to go? All right. This first, let me tell you about the name of it. Since it's on a grid, we call these a coordinate proof. All right, this is called the coordinate proof because it's on the coordinate grid. We need to show this as a rectangle. Somehow show it's a rectangle. So what is good enough to say it's a rectangle? Because you just can't say, right, I just can't. First of all, what do you know about a right angle? What do you know about a rectangle? Has a right? That's not good enough, though. I need more. Okay, I need more. And above, I have 3 ways listed how to show a rectangle. And for us in this class, I'm just going to say, do it this way, and we're good to go. All right, there are other options if you want to ever investigate it, but I'm going to just say, here's how we're doing it. We're going to show it's a parallelogram first, and then show it's got a right angle. So the first thing you're going to do with me in this proof is, first prove to me this is a parallelogram. First prove to me it's a parallelogram. Good news about these proofs, do it any way you want. Okay, remember on our last proof here with the rhombus question, this was the only way to do this proof. By proving the triangle side angle side, or angle side angle. There was no other way to prove the triangle's congruent other than that. But here, let's start it off with you guys. What makes it into a parallelogram? If I knew what? What would make this into a parallelogram? Scott, one way. Okay, so if you wanted to show congruent sides, you could. And it'd be fine. How else could I show a parallelogram? I could show congruent sides. I could show what else? Congruent angles. Yep. So I could show these angles are congruent. These both pair are congruent. Luke?
If the opposite sides are congruent and parallel.
So if you want to show this is congruent and those same pair are parallel. Everyone agree? All right. Now the question is, how do you do that though on a graph? Right? How do I show sides are parallel and sides are congruent on a graph? Well, we're going to need to revisit some old formulas, unfortunately. Okay, we're going to have to revisit some old formulas. First, let's talk about how do I show lines are parallel on a graph? What formula am I going to need here? Scott? Slope formula, correct? All right, so if you want to jot some things down on top, off to the side, because you're going to need some room at the bottom to do the actual proof. So show sides are parallel. Scott says I need the slope formula. And what's got to be true about the slopes if lines are parallel? The slopes have to be equal to each other. So show sides are parallel. I need slopes are equal to do that. Well, I'm also going to have to show you sides are perpendicular to each other. Anybody remember how to do that using slopes? If 2 lines are perpendicular, the slopes are not equal. Romeo, up now. They are negative reciprocals, right? Slopes are negative reciprocals. Well, slope might not be the only formula I'm going to need here. What if I need this? What if I wanted to show the sides congruent instead? I'm going to need what formula now? What formula am I going to need? Come on, we've used it a ton this year. To show 2 sides or 2 lengths are equal. Scott, I need to say distances are equal. Yep. Bless you. All right, distances are equal. And then finally, this is also an option because remember in a parallelogram, diagonals bisect each other. What was that point called where the diagonals intersect? They intersect at the what? Midpoint. So if you want to show diagonals bisect each other, midpoints are equal. So we're going to have to revisit these 3 formulas, slope, distance, and midpoint, while we do these coordinate proofs. So let's revisit them right now. Anybody remember the letter for slope? M. Anybody remember how to find it? I'll give you the credit before I wrote mine up. Okay, rise over run. That can definitely be used. Some of you might like plugging numbers in, and if I want to plug actual x and y values in, how would I find it that way? What goes on top? Change in y's, y2 minus y1 over x2 minus x1. Yep, good. So that's the way I could find slope. You guys remember the distance formula? Uh-oh. Not plus, no plus inside. Big square root.
Is it x2 minus x1 squared plus y2 minus y1 squared?
And finally, midpoint. Let's review the midpoint formula.
x1 plus x2 divided by 2 comma y2 or y1 plus y2 divided by 2.
Okay. Oh boy, here we go. They're not that bad. These aren't that bad at all. It's just number one, you got to be organized with your work because you're not putting in statements, reasons, and I've seen some of your writing, and it can't be all over your page. And then number two, we just got to make sure we got the correct formula and use it correctly. So go back to the rectangle problem now. Let's go back to the rectangle problem. So the way we're going to do this is we're going to show this a parallelogram first, and then we'll show it as a right angle because those two together make a rectangle. All right, we need to make a class decision here. You know, homework tonight, you can make your own decision, but class, we're all going to do it the same way. How are we going to show it's a parallelogram? Let's make a class decision. And via the answer to that is, it depends on you. All right, it depends on you. Which way we want to show? Do we want to show opposite sides congruent, opposite sides parallel? What do we want to do here? Talk to me. We want to use distance? Is that where we're going? We're not going slope. Okay, let's go. Here we go. Distance. Distance, people. How many distance? Even though people yell distance, now there's not a single hand out. Slope. Okay, slope it is. Ready? So here's how we're going to organize the organization of these coordinate proofs. You're still going to get me a step one right now. And now because you chose slope, you're going to find the slope of each line now. Find the slope of each side. So ready? Here's how I'm going to write it. M for slope. Let's start with QR. So the slope of QR is equal to, since it's already graphed, I recommend rise over run instead of plugging in the coordinates. So how many up and over do we need to go here? What is your rise and your run for QR? Up and over how many? Up 2 over 3, but we got to be careful. Everyone see how QR is drawn here? This is what type of slope? Negative 2/3. Can everyone do that? Because if not, if not, you're going to have to take point Q and point R and do y over x. Change in y over change in x. All right, look, we got to do it for all four sides. The slope of PS now. What's the slope of PS? Up and over how many? Up 2 over 3, and it's? Yeah, it should be. Guys, this is going to be a rectangle. There's no question about it. There's no fooling here. All right, if it doesn't come out to be the way you want, that's a user error. All right, it's going to come out to be a rectangle. All right, here you go. Let's do RS now. Slope of RS. What do you have? Up and over. Rise over run. 6 over
4.
4. Is that positive or negative? Positive or negative, RS? Positive. And if you want to reduce, go ahead, 3 halves. All right, keep going. We got one more, QP. And QP also comes out to be 6 over 4, or 3 halves. We're good? So step 1, you show me the formulas you're using. Now, some of you yelled out but didn't vote for distance. This would be where you would do all your distances if you chose to go that route. Step 2 now of the coordinate proof. Tell me what you learned from step 1. What did we just learn by doing these slopes? We didn't learn that it was a parallelogram yet. What did we learn about QR and PS? Go ahead. Same slope, so that means they are? Okay, so in step 2, you're going to say, hey, QR is parallel to PS, and what else? Are those the only 2 parallel lines? RS is parallel to QP, and just like in statements reasons, why? Give me a because here. How'd you know they're parallel? Because they have the same slope, or because slopes are equal. Tell me what you learned. Maybe you did distances. Now you tell me they're equal instead of parallel. Okay? It's whatever you learned from step 1. All right, so here's what we have. Parallel, 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 parallel. What is this? Okay, there we go. There's step 3. PQRS is a parallelogram, and just like you would in your reasons column, because opposite sides are parallel. All right, well, it didn't ask me about a parallelogram, right? It asked me about a rectangle. So now that we know it's a parallelogram, now we have to show there is one right angle somewhere. All right, so we keep going now. Keep going. How are right angles formed? Oh, wait. Do we have any perpendicular lines? Let's see. To show perpendicular lines, we show slopes or negative reciprocals. Look back at the work we did for slopes. Do we have any slopes that are negative reciprocals? All right, give me 2 slopes then. Or give me 2 lines that were, or 2 sides that were negative reciprocals. QR and PS. QR and PS aren't the negative reciprocals. QR and RS, fine, I'll take those 2. You could have taken a bunch of combinations. So now in step 4, we can say QR and RS are what? What symbol can I put in the middle? They are perpendicular because not because the graph looks like it, but slopes are negative reciprocals. And hold on, stop there, please, stop. Let's say at the beginning you chose to use distances. Fine. After you showed it was a parallelogram, I still need to show the slope of QR and RS to show me that they are actually negative reciprocals. It just so happens that we picked slopes, so it was convenient. I don't have to do it again. But does everyone see what I mean there? If you do distances first, and you're going to say it's perpendicular, this step right here in between better say, here's the slope of QR, here's the slope of RS, to prove to me that they are negative reciprocals. Okay? So you may have to show 2 formulas in one proof. Keep going. Well, again, pretend this is statements reasons. What would you put next after you said they were perpendicular? Where? I can't say everything is a right angle because I only said QR and RS. angle R, right? Angle R is a right angle because, again, think about it as statements, reasons. What would go in there? Yeah, perpendicular lines form right angles. Is it a parallelogram? I already said that. Is it a rectangle? I mean, sorry, is there a right angle? Put the two together. What do you have? Okay, so now step 6. PQRS is a rectangle because this one always trips kids up. What I'm going to have you right here. Because why is this a rectangle? Okay, yeah, I just can't say because it's got a right angle. I can show you a trapezoid that's got a right angle. That doesn't make it a rectangle because a parallelogram, which we just proved, with one right angle is a rectangle. Perfect. So that is how I would like you to prove a rectangle. Show it's a parallelogram, and we're all clear. That's you. If you're a distance formula person, do distance formula then. All right, to prove a parallelogram. But this is how we're going to prove a rectangle. Parallelogram, right angle. Questions? You just got through the tough one. Rhombus is a heck of a lot easier to prove. What do we know about a rhombus? What's the big property about a rhombus? All sides are congruent. That's how we're doing it. Nice and easy. I'm not even, I listed a couple options there, but I'm not even going to give you many. Yeah, here you go. Here's how we're doing it. We're going to show all sides congruent, and we're done. You could show it a parallelogram with some other stuff, but let's make it easy on ourselves. Let's just show all 4 sides equal. So go ahead and graph it, and we'll do that. All righty, got it all graphed here. All right, if you have a 4-sided figure that all 4 sides are equal, it's definitely a rhombus. Could be a square, but that's tomorrow's business, but it's definitely a rhombus. So what do you think we're going to put in step 1? What are you going to show me in step 1? All 4 distances, right? That's what you're going to show me in step 1. All 4 distances. All right, so first, anybody, it doesn't really matter what side. Let's go DC, I guess. You can go any side you want. So distance of DC. This is where I need to know the formulas, right? All right, so x coordinates of D and C are 6 minus 9 all squared plus y coordinates subtracted 5 minus 1 all squared. Let's see, what numbers do I get under there? Negative 3 squared? And what is it? I know. 9, positive 9, plus 5 minus 1 squared? 16. Square root of 25. Now this one's a nice one, right? Because what's it going to equal? Okay, now let me just mention something. I do not expect you to break it down if it's not already a perfect square. Just leave it underneath the radical and you're done. Okay, because every other side should have that number underneath the radical too. All right, so don't try to break it down if it doesn't become a perfect square. All right, we're not done, right? That's just DC. Let's go. Let's roll. CB. You guys can fill in the rest. CB, AB, and AD. You know what it should come out to be. All right, if it doesn't come out to be the square root of 25, that is user error. That doesn't mean this is impossible. How's it going? We getting 25s? Square root of 25 equal to 5? We getting 5, 5, 5? Okay, keep going, keep going. Remember, step 2 is always, what did you just prove in step 1? And you're not ready to say it's a rhombus yet. What did you just prove in step 1? If everything came out to be 5, what do I know about these 4 sides then? That's what you tell me. Oh, last proof it was these are parallel. Not this time. DC is congruent to CB, is congruent to AB, is congruent to AD. Because distances are or equal. Yep. And then congruent, 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 congruent. Is this a rhombus? Yep. I do not need to say it's a parallelogram. If you have 4 congruent sides in a quadrilateral, it is a rhombus. ABCD is a rhombus. What's going to be your reason here? ABCD is a rhombus because you could mention quadrilateral. That's fine. You don't even just say, hey, it's a rhombus because all sides are equal or congruent. Okay, so that's how I'd like you to show a rhombus. Show all 4 sides are equal. Rectangle, parallelogram with a right angle. Please, I'm begging you not to just copy down my versions tonight. If you have your own version that doesn't match mine, bring it to class tomorrow. Raise your hand at the beginning and say, how's this sound? All right, because there's so many different versions. I want you to do what you're comfortable with, not what I do. All right.